Okay, so now in example number 5, we're going to be actually given the zeros and writing the linear factorization. Now notice a couple things that are thrown here. We're given zeros as well as multiplicity in this example, and then here we're given fractions, which is not something that we have dealt too much with in our previous examples as far as identifying fractions. I think we only had like one example there of fractions. So we did talk about the multiplicity here, but again, the main important thing I want you to understand is this is like just the reverse process of what we've previously done. So here we have the polynomial. We factored it into a list of linear factors, and then we applied the zero product property to solve. So in the last example, we practiced, well, when we have it as a product of linear factors, we can go ahead and multiply them to get to our polynomial. So when we have our zeros, basically what we want to do is just work our way backwards. How can we take our zeros and write them as linear factors? And I think that main thing comes from is, where did the zeros again come from? So if we had something, just real quick, a kind of sidebar, just to kind of like refresh your memory. If I had, y equals, x squared, plus x, okay? And I go ahead and, find the zero, so I factor out an x, therefore it's x plus 1. Now I apply the zero product property because I have a product equal to 0, so I have x equals 0, and x equals, or x plus 1 equals 0. Okay, and then I have x equals 0, x equals -1, and now I can write them as 0, -1. Okay, so I did this process rather quickly, right? I went from here, factored it, zero product property, to solution set. Basically, all we're doing in this example is going from solution set, setting each of them equal to equal to x, writing them equal to 0, writing them as factors, and then multiplying them. So in the last example, we basically went from here to there. Wasn't that bad, just multiplying, right? So now what we're going to do is we're going to go from the solution set of the zeros to this factored form, so therefore we can multiply them, all right? So I'll just erase that because that was just kind of my instructional stuff, but now I'll kind of work through this step by step so you guys can see the kind of process that we're going to want to do. All right, so on the first one, we have 3 zeros, all right? And the basically way that I kind of describe this for the students is once you have your zeros, those are, this is written as a solution set. But we don't have to write the zeros like this. We could just write the zeros like this. X equals -2, x equals 3, and x equals 1, right? Now, we got these because we had them applied by the zero product property set equal to 0. So now what we're going to want to do is write these all set equal to 0. So therefore, I'm going to use inverse operations so that they're each set equal to 0. So I have x plus 2 equals 0, x minus 3 equals 0, and then x minus 1 equals 0. Okay? And then what we notice is, remember the zero product property says when you have a product of factors equal to 0, then you can set each and every one of those factors equal to 0. So basically, these are all examples of factors. So it's basically this is a factor, that's a factor, and that's a factor. So what I'm going to do is I'm going to take these factors and multiply them. And when I multiply them, I'm going to get the equation of the polynomial that I'm looking for, right? Or it could be the function of the polynomial, whatever the notation that you're being asked. In this case, let's do an equation. So I'd have y equals x plus 2 times x minus 3 times x minus 1. All right. Now, in this exact setup, there's really not any best way to be able to multiply these. It doesn't matter if you do these two first or these two first. So I'm just going to go from left to right. I'm going to multiply these two first. And I'm not going to use box method or distributive property. I'm just going to kind of do this in my head. X times x is x squared. I have 2 times x and then x times -3. So that's going to give me a -x when I combine those. 2 times -3 is a -6. Keep those in parentheses because remember it's this product times x minus 1. In this case, you could use the box method or you could just do distributive property again. And that's the way that I'm going to do it. I kind of don't mind doing distributive property in this case. So I'll just do, x squared. Oops, I'm sorry. So again, I'm taking this x squared and multiplying it by both of these terms. So that's going to be x cubed minus x squared. Now, another way you could do it, in the last example, I did a vertical method. You could also do the horizontal method, right? You could, just do everything horizontally and then just group your terms from there. So -x times x is a -x squared. Negative x times negative 1 is now a positive x. Negative 6 times x is a negative 6x. And negative 6 times negative 1 is a positive 6. So this method works perfectly fine as well. Some students will make mistakes with their signs. That's why I don't love this process. But it's rather quick, and it's pretty easy to write. So therefore, I have x cubed. This becomes a negative 2x squared. This becomes a negative 5x plus 6. Okay? Okay, where am I? There I am. All right, so let's move on to the other one. Now we're going to be talking about multiplicity. And if you remember, multiplicity is the repeated of the zeros, right? So we can kind of jumpstart some of this stuff, but if we wanted to, we could just, we could go back to, writing these as, here's my two zeros, right? That's x equals 0 and x equals 1. But remember, these are repeated. That multiplicity says it's repeated. So we basically have x equals 0 again and x equals 1 again, right? Now, when we have this, if I want to write them out like I did here, I don't really, I have x equals 0, x equals 0. Here I have x minus 1 equals 0 and x minus 1 equals 0, right? And if you write them, here's all of your factors, basically. So when I write them as my product of my factors, I have y equals, you could write x minus 0 times x minus 0, but why do that? Let's just write this as x squared. And then here, I have x minus 1 as a factor, and x minus 1 would be a factor, which is a binomial squared, x minus 1 squared. And again, if you've got to remember these relationships, it's going to help you so much. Binomial squared produce perfect square trinomials. So I multiply, it's going to be x times x is x squared, negative 1 times negative 1 is positive 1, but then remember you got these middle terms, so it's x times negative x plus x times negative 1, again, which would be a negative 2x. So if you didn't catch what I was saying out loud, just multiply this. Just remember it's x minus 1 times x minus 1. So just multiply that out. But what you'll get is x squared times x squared minus 2x plus 1. Okay, and then we can just apply distributive property here. And we get x to the 4th minus 2x cubed plus x squared. Boom, done. And again, it could be y, it could be f of x, whatever may be the case. All right, now onto the fractions. So I want to kind of go through this. Here's a fraction, right? And a lot of people will automatically get into and say, oh, well, then the 0 is x to the negative 1/2, which is true. That's actually fine. There's nothing wrong with that, except that when you multiply them, now you're going to have fractions, and that's not very good, right? We don't really want fractions. Nobody wants to do math with, fractions if you don't have to. But I want you to kind of see on this previous example where this 1/3 came from. The 1/3 came from not having x equals, 1/3, but it came from this factor 3x minus 1. And that's the idea that I want to bring to you is, yes, x equals negative 1/2 is the 0, but rather than adding the 1/2 to the other side to get it to be 0, let's use inverse operations. Because then we're going to avoid having to do multiplication with math, which is not going to be that great. So let's have x equals 3/4, and then x equals negative 1 and x equals 1. And we can do those rather quickly. I'm not worried about those. So rather than adding 1/2 to the other side, why don't we multiply by a 2 on both sides? Therefore, I would get 2x equals negative 1, and then I can just add 1 to the other side, and now I get a factor. I'm not going to use a parenthesis. Now I have a factor of 2x plus 1 equals 0. Over here, why don't we multiply by 4? Horrible 4. Why don't we multiply by 4 on both sides? Therefore, I will have a 4x equals 3. And then I just subtract a 3 on both sides. And now I have 4x minus 3 equals 0. And then obviously, these are going to be x plus 1, x minus 1, right? So let's go ahead and now just write the equation y equals. These, again, are my factors. I can rewrite these as, x plus 1 equals 0 if I add the 1, and x minus 1 equals 0. Sorry, I just ran out of space. So I'd have 2x plus 1. Don't like that plus sign. 2x plus 1 times 4x minus 3 times x plus 1 times x minus 1. Okay. Now this one's pretty nice because we can apply the difference of two squares here rather quickly. This one's not as nice. I mean, we can just use FOIL. It's not the end of the world. I'm going to do FOIL. I'm going to kind of do it in my head though. So 2x times 4x is going to be 8x squared. 2x times negative 3 is going to be a negative, so 2x times 3 is a negative 6x. 1 times 4x is a positive 4x, so therefore that's going to give me a negative 2x. 1 times negative 3 is a negative 3. Again, these are conjugate pairs, so therefore that's going to give me x squared minus 1. Now, in this case, I'm going to want to use I'm going to try using the box method, okay? So, and to do the box method for this, again, we have one side of a rectangle has 3 terms, and this one has 2 terms. So I'm going to create a nice little rectangle, and I'm just going to break it up into 3 columns and then 2 rows. Okay, and it doesn't matter if you do 2 by 3 or 3 by 2. Now I'm just going to take an x squared minus 1. Over here, I'll do 8x squared minus 2x minus 3. So to find the product, basically now what I'm doing is I'm finding the area of each and every one of these rectangles. And then again, the reason why I like this is it just keeps everything nice and organized. I'm not worried about negative signs, or like mixing things up. So now just find the length and width of each of these boxes. X squared times 8x squared is 8x to the 4th. I'm actually going to zoom in one more time. X squared times negative 2x is a negative x cubed. X squared times negative 3 is a negative 3x squared. Negative 1 times 8x is a negative 8x squared. Negative 1 times negative 2 is a 2x. And negative 1 times negative 3 is going to be a positive 3. Now again, usually if we have these in standard form in like the same descending order, we'll have terms combine on the diagonal. This doesn't go exactly that way. You can see that we have 2x squared terms, so I can just go ahead and combine those when I write my final answer. So my final answer is going to be 8x to the 4th minus 2x cubed. I can combine negative 8x squared and negative 3x squared, so that's going to be a negative 11x squared. And therefore then I have 2x, so a positive 2x, and then a positive 3. And there you go, ladies and gentlemen. That is how you go ahead and write the equation of the polynomial when given the zeros. And again, just a quick summary, take the zeros, even if you have multiplicity, just remember that's, basically write them as the factor with the multiplicity. But take your zeros, write them as factors, and then multiply them to write them as the polynomial. All right, and that's it. So now what the next thing we'll do is we'll just kind of work on a word problem.